Assalamu alaikum and welcome to Mathcast with Faria Yusuf. The topic for differentiation is connected rates of change, and this is going to be the fifth lesson of differentiation. Connected rate of change. So, as the word suggests, rate means we have to be considering all the parameters or the values which are changing with respect to time. So, values which are changing with respect to time. So we know whether we are talking about area, volume, radius, or any parameter, it changes with respect to time. So if I say that it is the area of a circular pond, let's say I have the area of a circle. Let's say we have this area of a circle where we should be given a radius also, because in the circle from the center we have the radius. So if I say that the area is changing, there is a rate of change of area, rate of change of area, that means I'm talking about the area of the circle, which is a pi r square. So rate of change of area means I'm talking about dA over dt, which means the area is changing with respect to time. Rate, again repeating, is with respect to time. Rate means it's time, any change which occurs with respect to time. So if we are saying that the area of the circle is changing with respect to time, then obviously it means that the area changes because there has to be a change in the radius. So which means that the radius in return is also changing with respect to time. So that means if the radius changes, then only the area is going to change. So area and radius, both of them, they are changing with respect to time here. So if we are talking about this circle, then we know that the area of the circle is given as a pi r square. And if I say that the area, there is a rate of change of area, which is given as dA by dt, then obviously this is the condition which happens because the area first needs to get changed with respect to the radius. So I will say that it is dA by dr, and in return I will say that the radius is changing with respect to time. It's rate of change of radius also. So in other words, I can say that this is rate of change of area, rate of change of area. Here I can have change of area with respect to radius, change of area with respect to the radius, which then is followed by it's the rate of change of the radius. It's going to be the rate of change of the radius. So this is how we will be making our connected rate of change equation, which is also called the chain rule. So we are following the chain rule to have the rate of change of connected rate of change equations in differentiation. So giving you another example, if we have y in terms of x, if I'm given another example, y in terms of x, and both of them, they are changing with respect to time. So there is a rate of change of y, rate of change of y, as well as a rate of change of x, and also it's followed by the rate of change of x. So again, as getting suggested, it's the time, it's the rate that we are talking about. So there is a rate of change of y, so I can say it's dy by dt. Y changes with respect to time, rate of change of y, which then shall be equal to the rate of change of y with respect to x, because the change in y occurs only if there is a change in x. So I can say y is dependent on x also. So there has to be a rate of change of y with respect to x followed by the rate of change of x, which is dx by dt. So this is how we will be making the chain equation for the rate of change of two variables with respect to time. Or even if I say that I have a volume, let's say it's the volume of a cube. Let's say I have this cube, and for this cube, I want to have the rate of change of volume. So for this cube, obviously, I will say that there is going to be length, width, and height of the same dimension. So let's say it's x centimeters or x unit. Then here I know that the volume is given as an x cube. So if the volume is given as an x cube and I want to have the rate of change of volume, so rate of change of volume will be given as dv by dt. So this then shall be equal to the rate of change of the volume with respect to x, v and x. V and x, we have the two variables connect. We have an equation connecting the two variables. So I can have the differential of the rate of change of volume with respect to x, which then shall be followed by the rate of change of x also. So it's going to be dv by dt here. So let's do some examples to clarify this topic and this explanation. So question 1, the radius r of a circle is increasing at a rate of 2 by r meters per second. So the unit here, it suggests that it is meters per second, therefore it has to be connected with time, and it means that it is increasing at the rate of 2 by r square meters per second. That means we are talking about the radius here, which is changing with respect to time. So if the radius is changing with respect to time, then I should say here that it is the radius which is changing with respect to time. Therefore, it's dr by dt, which is equals to 2 by r square meters per second. So I can see that the meter suggests the change of the unit of the radius, and per second suggests the unit of the time. Therefore, this is how I can say that this is going to be dr by dt. It's the change of radius with respect to time, or the rate of change of the radius. Second part, find the rate at which the area A is increasing when R equals 8. Rate at which the area is increasing. Again, the rate, which means it's the time of the area. That means they are asking us to find dA by dt. They are asking us to find the rate at which the area is increasing. So it's dA by dt, which we are supposed to find out. And this is when the radius is equal to 8 meters. So with area of the circle as a pi r square, I can get the differential of the area with respect to the radius, which is going to be dA by dr, which then shall be equal to 2 times pi. So it's a 2 pi, and r square reduces by 1, giving me an r here. So dA by dr, the change of area with respect to radius shall be equal to 2 pi r. Now we are supposed to find dA by dt. I know that to get dA by dt, I should first know that this area has to change with respect to the radius first, therefore it should be a dA by dr. So if I make our connected rate of change equation, then I can say that it's dA by dt, which shall be equal to the change of area with respect to r, dA by dr, and then the radius changes with respect to time, which is dr by dt. Now I do have dA by dr, which is a 2 pi r, and I have dr by dt also, which is a 2 by r square. So simplifying our r, I will be here left with dA by dt equation, which shall be equal to a 4 pi divided by r. So according to the question, I need to find this dA by dt when the radius is 8 meters. Therefore, if I substitute this radius as 8 over here, I will be getting dA by dt, which shall be equal to 4 pi divided by 8, or I can say that this is a pi by 2. So our dA by dt in exact terms shall be equal to a pi by 2, and the unit here shall be equal to, for the area, it should be a meter square per second, or in decimal values, I can say that this dA by dt is equal to a 1.57 meter square per second here, up to 3 significant figures. So this is how simple it is to get the connected rates of changes. So question 2, the side of a cube is increasing. So we have this cube in question, and the side of the cube is increasing at 0.2 meters per second. We need to find the rate of increase of the volume when the length of the side is 4 centimeters. So this means that for the cube that we have, we should be having the volume formula for the cube, and we know that for a cube the volume can be given as V is equals to x cube. So if this V is connected to x and they are asking us to find the rate of increase of the volume, then it means that they are asking us to get dV by dt, but V has to change first with respect to the length or the side length, which is an x. So it has to be dV by dx. And then we can say that it is the x which is changing with respect to time here. Now, the side of the cube is increasing at 0.2 meters per second. So there is one thing which is known to us, it's dx by dt, which is equals to 0.2 centimeters per second. And the length of the side is x, therefore x is equals to 4 centimeters here. So if I simply get my dV by dx, so if the volume was equal to an x cube, then obviously our dV by dx, this should be equal to a 3 and x reduced by 1, giving me an x squared. So substituting dV by dx as a 3x square and dx by dt as a 0.2 centimeters per second, I know the x value. The x value has to be a 4, where we need to find the rate of change of the volume. Therefore, substituting x as 4, I should say it's 3 times 4 the whole square times 0.2, or further I can say it's a 3 times 16 times 0.2. And so this rate of change of the volume, it comes out to be a 9.6, and the unit for the volume is going to be meter cube, and for time it should be per second over here. So this is then going to be the answer to this question. So the next question that I have chosen is from summer 2015 paper 1 variant 1, and it is question number 2 in the paper. And the question says, the diagram shows the curve y equals to x square. This is the curve y equals to x square, and the points x negative 2 comma 0, x negative 2 comma 0, this is the point x here, and p, which is p comma 0. The point Q here, it lies on the curve, and PQ is parallel to the y-axis. PQ is parallel to the y-axis. So express the area of the triangle XPQ in terms of P. So XPQ in terms of P. So if I just look at this diagram closely, to have the coordinates of Q, I can say as Q is just above P, as it lies on the line PQ, which is parallel to the y-axis, therefore it needs to be a vertical line. It has to be above P, and therefore I can say that the x-coordinate of Q is a P here. And the y-coordinate, as this Q lies on the curve, which is y equals x square, I can say that the y-coordinate here is a 2x square. So if this is a 2x square, so for y equals 2x square, when my x is a p, I can say that my y value here needs to be a 2p square. Therefore, instead of x, I can simply say that the y coordinate of q has to be a 2p square. So I have the x and the y coordinates of q in terms of p now. Part 1 is asking for the area of the triangle XPQ. So to solve this area, part 1, area of the triangle XPQ, I need to have the area of the triangle XPQ. So this area is given by half into base into height. The base here is xp, the base here it's xp, and the height here is going to be pq. So for the base as xp, I can say that as I'm going to have the length here, I can simply say that this length is going to be a p plus 2. So xp is a p plus q, and pq is obviously going to be from the x-axis up till the point q. As it is a vertical line, I should say that this height is going to be a 2p square. So just substituting these values, xp is going to be a p plus 2 and pq is a 2p square. So I can get the area, solving the 2's, I can say that the area of the triangle xpq shall be equal to a p square times p plus 2 here. And I can say it is a unit square for the area unit. So this is going to be the area of the triangle xpq in terms of p here. The second part of the question says the point P, this point P moves along the x-axis at a constant rate of 0.02 units per second, and the Q moves along the curve so that PQ remains parallel to the y-axis. So few things to underline here are, number one, point P, it moves along the x-axis. So point P is moving along the x-axis at a constant rate of 0.02 meters per second. So this is going to be point P here, point P which is moving along the x-axis at 0.02 units per second. And then they are saying that Q moves along the curve so that PQ remains parallel to the y-axis. So this means along the curve, Q has, as P is moving along the x-axis, our Q shall also be moving along the curve so that at all points I can see that Q needs to be parallel to the y-axis, meaning if the Q lies here, if the point P moves along the x-axis, then Q has to be just on top of it here, parallel to the y-axis. If P is at this point here, then our Q needs to be parallel to the y-axis. So this is how they are moving, and with respect to that, what I can see is that in all the cases they shall always be making a right angle triangle, and this is how the area of the two of the triangles shall be changing with respect to P here. So as already we have the area which is with respect to P, they are saying find the rate at which A is increasing when P is equals to 2 units. So we have this area which is in terms of P already. I have this area which is in terms of P already as P square times P plus 2, or I can say it's the area which is equals to a P cube plus 2P square. So area is in terms of P, so therefore I can say that the area is actually changing with respect to P. So if I can have the area which changes with respect to P, and then if they are saying rate at which the area is increasing, that means if I need to have the rate of change of the area dA by dt when our P is equals to 2 units, then to make this rate of change of the area equation, I can say it's dA by dt. I have my area changing with respect to P, so I can say it's dA by dP, and then this dP and then this P changes with respect to time here. And again, they are saying that the P moves along the x-axis at a rate of 0.02 units per second. That means they have also given us the rate of change of P, dP by dt, which in this case is equal to 0.02 units per second. So the only thing that I need to have is my dA by dP. So if the area here was PQ plus 2P square, then I can say that the change of area with respect to P shall be a 3P square plus a 4, 2 times 2, that gives me a 4, and P square reduces to P here. So if P was equal to 2, then I can get the value of dA by dP, and this value then is going to be 3 times 2 the whole square plus 4 times 2, and this is going to be a 12 plus 8, and then this is going to be a 20. This is dA by dP. This is going to be a 20. Area obviously is unit square, and P is also a unit. Therefore, the rate of change of area with respect to P shall be having the unit as 20 units here. So in this rate of change of equation, connected rate of change of equation, dA by dt, I can substitute my dA by dP, which is a 20. dP by dt was already given, it was a 0.02, and I can say that this value here is going to be 4 divided by 10, which is a 0.4 unit square per second. So this is then going to be the rate of change of the area for this question. So the fourth question is chosen from Summer 2018 Paper 1 Variant 1, and it's question number 2 in the paper for 4 marks. And the question says, a point is moving along the curve y equals 2x plus 5 by x in such a way that the x coordinate is increasing at a constant rate of 0.02 units per second. Find the rate of change of y coordinate when x equals 1. So we have here y, which is in terms of x. So y is equals to 2x plus 5 by x. And the point is moving on this curve in such a way that the x coordinate, so let's underline the keywords here, the x coordinate is increasing at a constant rate of 0.02 units per second. So it's the x coordinate which is increasing, so I can say it's dx by dt, which is increasing at a constant rate of 0.02 units per second. So I have y, and we need to find the rate of change of the y coordinate, and this is when our x is equal to a 1. So if I make this rate of change equation, then I should say here that the y changes with respect to time, or the rate of change of y should be equal to, first the y changes with respect to x, as y is in terms of x, and then x is changing with respect to the time, which is already given to us as a 0.02. So solving further for dy by dx, our y equation is given as 2x plus 5x to the power minus 1, or I can say that my dy by dx, the change in y with respect to x, shall be the differential of 2x is a 2, 5 gets multiplied by negative 1, giving me a negative 5, and x then should be to the power negative 2 here. And again, they have said that this should be found when x is equals to 1. So in dy by dx equation, I can substitute this x as a 1. So x is a 1, so I can say it's 1 the whole square, or I can say that it's dy by dx now, which then shall be equal to a negative 3 here. So this is going to be a negative 3 units. So to have my dy by dt, my dy by dx value, which I found was a negative 3, dx by dt is a 0.02. So the rate of change of this y value here, I can see, is a negative 0.06 units per second. So negative sign, what this negative sign means is that here it should be the decrease, the rate of change of y is a negative, which means that there is a decrease in, it's going to be a decrease in y with respect to time. So with time, with the passage of time, there has to be a change in y, which should be a decreased value for this particular question here. So this is how these equations or these questions, they can be solved to get the answers. So let's do more examples to clarify the concept. So the fifth question is chosen from Winter 2015, paper 1, variant 2, and it's question number 3 in the paper. There are two figures given to us, and the question says, figure 1 shows an open tank in the shape of a triangular prism. The vertical ends of ABE and DCF, they are identical isosceles triangles, and angle ABE is equals to BAE, which equals 30 degrees here. The length of AD is 40. The length of AD, meaning it's the height of this triangular prism, which is a 40. The tank is fixed in position with the open top ABCD as horizontal. So water is poured into the tank at a constant rate of 2000 centimeter cube per second. So let's underline this keyword. It's 2000 centimeter cube per second, and as the units are suggesting, this is actually the change in volume. Centimeter cube represents the volume per second, meaning it's dV by dt, which shall be equal to a 200 centimeter cube per second. So even by looking at the units, I can just say that this is dV by dt given to us. The depth of the water, t seconds after filling starts is h centimeters. So after the filling starts, the depth of the water, it is given by h centimeters, as in figure 2 here. Part 1. Show that when the depth of water in the tank is h centimeters, the volume of the water in the tank is given by V, which equals 40 square root of 3h square. So they are asking us for the volume. They are asking us for the volume here when the depth of the water is h centimeters, and this should be given as a 40 square root of 3h square. Now, if they are asking us for the volume, then there is one thing that I should be knowing, and that is that the volume of this triangular tank is given as the base area, which is area of the triangle ABE, times the height or the depth of this prism here. So first thing is to find the area of the triangle ABE. So if I draw this ABE here, and this is going to be the height of the water to the level the water has been filled here. So I can say that this angle here is a 30 degrees. This angle here is also a 30 degrees. So to get the area of ABE, I should be getting the height here. Let's say that this is my x, and at this point, if being an isosceles triangle, from the midpoint, I can have this right angle triangle here. So with respect to this triangle, another thing that I can note here is that I have this x and y. I am getting this right angle triangle with respect to the midpoint being the triangle as an isosceles triangle. This angle is 30 degrees, and I have this h here. So with respect to this, I can see that this is my base or the adjacent, and this here is going to be the height. So I have the right angle triangle. I need to find out the base xy, and I need to have I have the height in terms of it. So here I can say it's tan of 30 degrees, which then shall be equal to perpendicular or the opposite over base. So tan of 30 degrees here is going to be 1 over square root of 3, which shall be equal to h over the base, which is xy, or further I can say that my xy is equals to square root of 3 times h. So if I need to have the complete area of this triangle, complete area of this triangle here, complete area of this triangle here, then what I have obtained is from the middle I have obtained this length in terms of h, which is going to be square root of 3h. So that means if I need to have the complete base length here in terms of h, then this shall be equal to twice of square root 3 and h here. So the base area of ABE, so the base area, this was A, B, and then E. Then we have just said that AB or XY in this case is square root of 3 times H. So here I can say that the base area of ABE to whatever depth H the water has been filled up to can be given as 1 by 2 into AB, or any base, which in this case can be twice of XY, times the height to which the water has been filled. So the base here, the base length here in terms of h is twice of square root of 3h, and times height, meaning it should be multiplied by h again. So in this case, the two get solved, simplified, and I can say that the area of the triangle ABE, which is actually the base area, this was actually the base area, this then shall be equal to square root 3h square. We have already discussed that the volume of this triangular prism is given as area of triangle ABE times depth, and the depth according to the question is AD, which is a 40 centimeters. So it should be the area, the volume, which should be the area of this base, which is ABE, times the depth, which is a 40 here. So if I just substitute the volume with the base area as square root 3h square multiplied by the depth, then I can say that the volume here is going to be 40 square root of 3h square unit cube here. So this is what the question asked us to show, that the volume in terms of h can be given as a 40 square root of 3 h square, and we have shown this question here. Second part, find the rate at which h is increasing. Find the rate at which h is increasing when h is equals to 5. So we have obtained the volume in terms of h. So if we have this volume which is in terms of h, then according to this, I should say that the connected rate of change equation shall be for dv by dt, which then shall be equal to dv by dh. Obviously, from volume in terms of h, I know that volume has to change first with respect to h, so that our h is changing with respect to time. It's dh by dt. Question is asking for the rate at which h is increasing when h is equals to 5. So they are asking here for the rate at which h is increasing. So it's dh by dt. This is what the question is asking us for when the height is equal to 5 units. So this is what the question is asking us for. So to get this, to solve this question, what we already know is that in this question, they have already given us that the water is being poured into the tank at a constant rate of 200 centimeter cube per second. So that means this dv by dt is already given in the question as a 200 centimeter cube per second. dv by dh, I can get my dv by dt. Let's start picking in the data. It's dv by dt, which is equals to 200 centimeter cube per second. And to get dv by dh, it's the volume, which is equals to 40 square root of 3h square. From here, I can get dv by dh. So this 2 gets multiplied by 40 square root of 3, and h square gets reduced by 1 as h. H was equal to a 5. Therefore, if h is equals to a 5, I can just substitute this h as a 5 here. So this is 80 square root of 3 times 5, or I can say it's a 400 square root of 3 here. So I can substitute this dv by dt, which was given as dv by dt. We already had dv by dt and dv by dh times dh by dt. So to find dh by dt, let's substitute dv by dt given to us as a 200. dv by dh is a 400 square root of 3 into dh by dt. Solving, I can simplify the two zeros, and here I can say that my dh by dt can be written as a 2 divided by a 4 square root of 3 units per second. Or to solve it further, I can say it's a 1 by 2 square root of 3 units per second, or in decimal values, I can say that this dh by dt shall be equal to, this dh by dt comes out to be a 0.2887 units per second, or up to three significant figures, I can say it's a 0.289 units per second. So this is how this question then gets need to be solved. The next question is chosen from summer 2016 paper 1 variant 3, and it's question number 7th in the paper for 7 marks, and the question is asking for the point Pxy is moving along the curve y equals x square minus 10 by 3 x to the power 3 by 2 and a plus 5x in such a way that the rate of change of y is constant. So the rate of change of y, this needs to be a constant. And find the values of x. We need to find the values of x at the points at which the rate of change of x is equal to half the rate of change of y. So this is the only hint that is given in the question. So according to the hint, they are saying it's the rate of change of x, meaning it's dx by dt, the rate of change of x, it should be equal to half the rate of change of y, meaning it's half of dy by dt. In other words, I can say it's dy by dt, which then shall be equal to twice of dx over dt. So with respect to that, what I can see here is that I have my y in terms of x. So the equation, the connected rate of equation that I should be having here is for dy by dt, which then shall be equal to dy by dx, as y is in terms of x. So I should be having dy by dx times dx over dt. So this is what the question is asking us for, and according to the question, we can see that dy by dt equals twice of dx by dt. So for dy by dt here, I can substitute twice of dx by dt, because here I have already found out, according to the statement, that is rate of change of x is equal to half the rate of change of y. It's dy by dt, which shall be equal to twice of dx by dt. So I will be substituting this dy by dt by twice of dx by dt here, which then shall be equal to dy by dx times dx over dt. So one thing that I can see here is that on both the sides I am having dx by dt, which can get simplified, so that I will be left here with 2, which is equals to dy by dx. And dy by dx, if my equation given to us here was y equals x square minus 10 by 3 x to the power 3 by 2 plus 5x, I can get the differential of y with respect to x as a 2x minus 3 by 2 times 10 by 3, and x reduced from 3 by 2 to 1, that will give me a 1 by 2, and plus 5x shall be reduced to just a 5 here. So dy by dx, we already have this value of dy by dx here, we said it's dy by dx, which is equal to a 2. So I will be substituting this dy by dx as a 2 here, and then here I will be left with 2x minus the 3 gets simplified, the 2 gets simplified, so that I will be left here with 5x to the power 1 by 2 and a plus 5. Or further solving it, I can say it's a 2x minus 5x to the power 1 by 2 and then plus 5. 2 from the left side taken to the right side gives me a 5 minus 2, that is a 3. So I should say it's a 3, which shall be equal to a 0. So this equation here can be taken as a complex disguised equation, and I can say this is m, which is equals to x to the power 1 by 2. Therefore, m square will be equal to x. So I can say it's a quadratic disguised equation as 2m square minus 5m plus 3, which is equal to 0. I can factorize this equation as 2m minus 3m and a plus 3, which is equals to 0. 2 3s are 6, negative 2, negative 3, that gives me a 6, and then 2 times 3, that is also a 6. Therefore, I can factorize this with negative 2m and a negative 3m. 2m can be taken as common. I'll be left here with m minus 1. Negative 3 can be taken common, left here with m minus 1, which is equals to 0. Therefore, it's going to be m minus 1 and 2m minus 3, which is equal to 0. So I can say that from here m has two values, m equals 1 and m equals a 3 by 2. So m is actually x to the power 1 by 2, and we need to have the values of x. Therefore, I'm substituting m here with x as a 1 by 2, which equals a 1, x 1 by 2, which equals a 1. To get the value of x, I will be squaring both the sides, so that here I can say that x has a value as a 1, and here x has a value which is a 9 by 4 here. So x has two values. One, it's a first one is a 1 and the second one is a 9 by 4, and this is what the question was asking us for. The question asked us to find the values of x, at the points at which the rate of change of x was equal to half the rate of change of y. This was the given condition, and with that given condition we have solved the entire question and gotten the values of x here. So this is how the questions on this topic can get solved, and I've tried to get the complex questions or the questions which need some explanation to clarify the concept for you people. So I hope this topic is clear now, and let's end the video. And this was the end of differentiation, and in the next video I shall be doing some questions from past papers. So till then, best of luck and see you all in the next video. Allah Hafiz.